Hello, and welcome to the live stream of Intuitive Machines 1, which is a spacecraft which is planned to go and land on the south pole of the moon. This is actually a really interesting launch because, well, the launch has already happened. It happened about 6 days ago. Uh, but this is a really interesting event because this will actually mark, if it's successful, the first private landing on the lunar surface. There's been a couple of countries that have been able to pull it off, with the United States, Russia, the Soviet Union, Japan, and India, most recently India. But now, potentially, there's a new demographic of people that are going to be landing on the moon, and that would be private corporations. This mission has been something that's been funded by NASA. They have a new program where they're trying to get commercial companies that are able to perform these types of activities, specifically so that we can put payloads onto the moon. So if like NASA or other space agencies and even commercial companies want to take payloads and send them to the moon, now we will actually have a dedicated infrastructure and companies that are working to do this. And it's not just Intuitive Machines. There's also a couple of other companies that are competing for these contracts. And yeah, Intuitive Machines happens to be the first one right now, and we're going to see if they're going to be able to make this work. So over the course of today, we're going to go over what's going on. We're obviously going to watch the live landing of the lander, and also some of the maneuvers it's going to make on the way to that, and we'll explain kind of what's going on with that as we go along. Yeah, and hopefully we'll get to witness a little bit of history. A little bit on myself. My name's Josiah. I'm the chief engineer at Astra, which is a student rocketry group which operates out of Bremen. And we're not really, obviously we're not a private commercial company or anything, but we're obviously a lot of students that are really excited about space and space activities. And come on, what's more exciting than going back to the moon? Come on, we've been waiting for this forever. And this is kind of like the start of the Artemis program, and eventually this is going to lead, hopefully, to humans going back to the moon, and in the far future, hopefully much further. So it's always exciting to be part of that history, at least in the viewer seat anyway. And of course, a lot of us are looking forward to potentially being able to participate on an engineering level. So yeah, that's part of the reason why our group exists. We want to develop our skills as engineers. Currently, right now, we're building rockets, which we're hopefully going to build a rocket which will go to space in the near future. But of course, we can always learn some cool things about the commercial companies and what they're up to. And there's lots of interesting technical details about this lander, which are a bit interesting for the world of rocketry anyway. So without further ado, we're going to be switching to the live stream as soon as NASA starts it up. It'll be in about 10 minutes or so. It's going to be kind of going really quick into the activities, though, because they kind of moved up their schedule a little bit. We're now just an hour and a half away from the landing. But the actual activities to get to the moon take a little bit longer, so we're actually only 20 minutes away from the first burning activities. Because right now they're in a 90-kilometer orbit, and they need to actually lower that orbit down to a 10-kilometer orbit, and then they're going to do kind of like a half orbit around the moon, and then they're going to do their landing at that point. So yeah, the engine's going to be on and doing stuff in just around 20 minutes here. But before we get into that, obviously we want to understand what's going on with this lander, what's the mission profile, what's interesting about the lander technically. So I think we'll kind of just dive into a little bit of that. So you can see here that in this diagram, there's a bit of a mission profile that the vehicle has been going on for the last little while. It's already gone through a bunch of steps. So it's been launched, it's done its lunar insertion trajectory. That was all done with the SpaceX rocket, the Falcon 9. The payload went all the way to the moon. It also did a deorbit burn where it went into this 90-kilometer lunar orbit. So now we're moving into the next phases where it's going to actually lower that orbit a little bit. So it's going to come down from that 90 all the way down to 10 kilometers. It's going to do a half orbit, and then it's going to start going into terminal guidance where it's going to be going through different phases quite rapidly. Those are all those milestones you see at the end there. And eventually that's going to end, of course, in a soft touchdown on the moon. And in each of those phases, there's going to be different levels of burning that are going to be happening with their engine. But the main thing that's going to happen is first it's just going to be trying to scrub off all that horizontal velocity that it has with the moon, because it's going to be moving at a roughly 1.6 kilometers per second. And of course you want to end up at 0 at the end. But most of that velocity is just sideways. So for the first 90 or so percent of the burn, they're just going to be burning sideways and coming down to the lunar surface that way. Once they've scrubbed off all of their velocity to basically 0, then the vehicle is going to be falling just vertically. And then that's where they're kind of going into their terminal guidance, where they're going to try to exactly pick a landing spot where they'll be able to settle down onto the surface. So yeah, we'll be going through, as the mission profile goes, they'll obviously be calling out each of these activities, and you'll be able to track the success of the mission as we go. And hopefully it will be fully successful, and you'll see just how interesting and advanced this lunar lander really is, because there are some cool stuff that is on board. So where is it landing? Well, the Intuitive Machines mission is all part of a bunch of missions which are planned to go to the moon. So here you actually see all the landing spots that the commercial lunar payload services contracts are giving. So I think there's eight or nine locations all around the moon where there's going to be landings. But today it's Intuitive Machines 1, so I think it's marked number 6 or number 7. Yeah, I think number 6, which is, if you look at the third profile of the moon, that's looking at the South Pole at the center. So we're almost landing right on the South Pole, which is kind of an interesting landing spot, because this is actually where there is supposed to be a bunch of water. So the idea is that, well, this could be an interesting place because in the future humans could go there and maybe have access to water. This is a good thing for humans, of course, because humans need water to survive. But it's also good for like infrastructure and rockets, because the rockets can actually use the water in order to make fuel. A popular form of fuel is, of course, hydrogen and oxygen. And what's water made out of? Hydrogen and oxygen. So you can just split the water apart and make rocket fuel. There's obviously a bunch of other stuff you can do. Usually you need water for pretty much every industrial process that we do on Earth. So having access to water is kind of a really big deal. This is one of the key elements of these missions, is trying to evaluate just how much or how available water is in these areas. For this first mission, though, I think the key thing they're looking for is just how can we land on the moon, and how can we get commercial companies to do it, and is it reliable, and can we deploy payloads and things like this, and carry payloads to these destinations. And I think that's what Intuitive Machines is trying to prove in this case. So just getting to the lunar surface is a huge win. And actually just getting this far, where they are right now, is still pretty cool, because a couple of landers that have gone before, of course with commercial companies, haven't quite made it this far. So they're already ahead of the game just by getting to where they are right now. But yeah, once they land on the moon, it'll probably, if you were standing and had a camera on the outside, it would probably look something a little bit like this. Of course, this camera view is not available because they're not landing beside something else that landed on the moon. But hopefully we'll get some form of live pictures or live video. I'm not sure if it'll actually be video, because usually the bandwidth for vehicles like this across that distance is quite limited. But we might get some live pictures or some sort of update from the team as they go, which should be pretty interesting. So be sure to stay tuned. There's also some interesting things about that engine that you see that's burning there. It's not really the typical space engine that would be used on this type of a mission. Usually you'd have some sort of hypergolic propellant, which just means that when the fuel and the oxides are mixed together, they just immediately react and you get thrust. This is pretty typical because it's very reliable. But the problem with hypergolic propellants is that they're actually quite toxic. So when you're building them on Earth and testing them and operating them, it's kind of dangerous. Basically, if you touch them, it's like a serious situation that could result in death. So yeah, if you're going to be doing like lots and lots of missions, it's probably not the best way to operate, just because of the safety hazards that are involved. But this engine is not going to be using those hypergolic propellants. Instead, it's going to be using liquid oxygen and methane. And this is kind of a new idea in space and rocketry in the past 10 years. There's actually a lot of companies that are kind of switching over to this type of engine design, simply because it is kind of a marriage between performance while also maintaining some simplicity and some safety. So obviously, oxygen and methane are not toxic. You do have to cryogenically store them, which is a bit of a challenge, especially for a lunar mission because you're exposed to the sun for such a long period of time. But Intuitive Machines has kind of managed to make this work. Their engine has been working quite well in the past couple of days. They managed to do some engine tests on the way to the moon, plus they were able to do their full insertion burn and some orbital maneuvers. So it's clearly the case that this engine is functioning quite reliably. So I'm looking forward to seeing how that reliability works in an actual lunar landing scenario, which we should be seeing relatively soon. For anyone who's joining right now, we are just about 13 or 14 minutes away from the first orbital maneuver. And the landing should be happening in just under an hour and a half. So things will be happening quite quickly once the NASA live stream starts up. And that's what we're going to be looking at. So we'll get to watch the entire situation unfold in completely live. So this is another really cool thing about these, is that it's nice to be able to see this type of activity 100% live and in reasonable quality. I know that the Apollo missions were also streamed live, but they definitely suffered from a bit of quality issues. But yeah, we'll see how it goes. Yeah, so you mentioned that the NASA live stream starts in 2 hours. Let me just check. It could be the case that they just switched it. It's possible. Just give me 1 second. Let's see. So if we switch to the live screen. Yeah, it looks like they've pushed back a little bit. Interesting. Well, this is actually relatively expected a bit. It could happen this way. The reason for the pushback, I'm sure, is because they're deciding to try the next orbit. Interesting. So basically, because the mission right now is in a 90-kilometer orbit, they can kind of pick whichever orbit they want, right? So the orbiter is going in this polar orbit, north to south, and it's targeting a landing site that's all the way down at the South Pole. So because of the nature of the orbit itself, you pretty much can land at any orbit you want. So I guess they've decided basically to push back until that next orbit. Now I'm just going to go look and see what Intuitive Machines is saying about this. Because I'm sure they have something to say about it. I'm just checking their Twitter right now. They don't have anything there. Let's see. So they just gave an update on the landing time, I believe. Yeah, so they're confirmed. It's a confirmed thing. This is exactly what's happening. So they're actually waiting until the next orbit. They didn't mention the reason why. But they are waiting to the next orbit. So we won't see the landing for another 90 minutes or so. So it's going to be an extra little bit of time. The orbit they're in right now takes about just under 2 hours in order to complete. So that's why obviously NASA's stream has been pushed back by 2 hours. Uh, yeah, but I think that maybe we should take a small break, and maybe we'll come back in an hour or so, and then we can update on the progress and if there's any further updates that they have. So maybe just stay tuned, and I'm just gonna go to a pause screen for now. I mean, unless you guys want to ask questions or something about the mission, then I can stick around and maybe we can chat a little bit. That's also cool. Let me know what you guys think. All right, Taro. No problem. I think we'll take a small pause and we'll come back in about an hour. I'll leave it on the start screen. So if you want to see some cool animations of a lunar landing, you can always jump in for a minute or two. Anyways, take care, and I'll see you again in an hour. Hello and welcome back to the live stream of the Intuitive Machines 1 landing. Um, we were delayed there for about 2 hours because they decided that instead of landing on the first orbit attempt, they went back around. So we had to wait again for the orbiter to get all the way back around the moon to the restart point where they can start doing the orbital deceleration burn. NASA is going to go live in about 10 minutes, and the first part of the deceleration burn is going to start in 19 minutes. So we're going to be waiting for that a little bit. But in the meantime, we can talk a little bit about the lander itself and how it's built, what its purpose is for, and maybe get some insights into how the mission is going to play out so that we don't get too confused while the live stream is happening. Also, if you have any questions about the lander and what's going on, certainly drop them in the comments. I can answer a lot of them. My name's Josiah. I'm a space engineer, and I'm a student at a student rocketry group called Astra Bremen. This is the channel that I'm streaming from right now. Of course, being a space enthusiast and studying that material right now, I can maybe provide some insights into different parts of the mission, and yeah, hopefully we can get an idea of what's going on here. And some things about the monumentality of this mission. This is the first time America is going back to the moon for a landing in 52 years, so this is kind of a pretty big deal. And if they manage to stick the landing, the Intuitive Machines lander, it'll actually be the first commercially built lander that will land on the moon. So it's a big step forward for commercial industry. It was also launched by a commercial rocket company, of course, SpaceX. So it's basically a fully commercial mission. NASA is just paying for it. That's all. So without further ado, we can get into a little bit about what the mission profile is going to be. So we can see here, this is kind of the way the mission has been unfolding so far. It's gotten through a lot of the first stages of the whole approach. So it's launched, it went on the lunar insertion trajectory, it did a deceleration burn, got into a circular orbit, and that's where we are right now. We're basically just orbiting around the moon. What the next thing we're looking for now is to start the deceleration burn. It's going to do a quick orbital maneuver where it's going to go from a 90-kilometer orbit down to a 10-kilometer orbit. That's the first thing that we're going to be seeing. Then it's going to wait for another half orbit or so, and then it's going to start performing the full landing maneuver. The landing maneuver in total is going to be about 10 to 15 minutes. Basically, the reason why it's so long is because it has to basically get rid of 1.5 or 1.6 kilometers a second of velocity, because it's going really fast horizontally to the surface of the moon, even though it's not very high above it, so to say. So first it's going to try to get rid of all that horizontal velocity until it's almost stopped. And then basically it's going to try to come down pretty much vertically for the last couple hundred meters and find a perfect landing spot with its specialized equipment, like things like LiDAR and live image tracking. It takes a picture of the surface and basically figures out where the best spot to land is. Yeah, I'm hoping we'll get some live footage of that process happening, because I think that'd be really cool. But let's not get too excited, because it is quite far away and their bandwidth is probably going to be quite limited. So I'm not sure exactly how much of it we're going to get live, but I hope we at least get some live footage. So just to give you a little idea of where it's landing, here you can see the whole mission profile, which the Intuitive Machines 1 is part of, is the Commercial Lunar Payload Services program, and they have chosen 8 landing spots all around the moon for this whole program. And the landing spot that we're going to be targeting today is number 6. It's on the right hand side there with the South Pole view of the moon. So we're very close to the South Pole. And the reason why we're going so close to the South Pole is because, of course, we suspect there might be some ice contained at the South Pole. That's interesting for us because if there is ice, we can actually use that in future manned missions. Ice is really valuable, obviously, because, well, humans can use it, right? We can have drinking water. But it's also really important for the fuel. that a spacecraft has, because a lot of rockets will use hydrogen and oxygen as a fuel and oxidizer. And this rocket itself, on board the Intuitive Machines mission, is actually using liquid oxygen. It's using methane as well, so it wouldn't really be able to get the methane from the water, but at least it could get the oxidizer in the form of oxygen. So in the future, this is going to be probably a little bit more familiar of a mission profile, and also a good location to go to if they actually manage to find evidence that there might be some water. So that's kind of the purpose of the mission, so to say. But to be clear, the main purpose is basically to show that they can actually pull off a landing. There's a bunch of payloads that are on board the vehicle. A lot of them are commercial. A couple of them are NASA payloads themselves. So if a company can show that they can reliably land things on the moon, then this could create a commercial environment where you can actually sell the ability to take things to the moon, which of course is interesting if we're trying to build up lunar infrastructure and things like this. It's most interesting for NASA because they're trying to build basically a mini base on the moon in the next couple of years. So obviously we need to have this capability in order to do that. So this is where it all starts. Intuitive Machines, can they get to the moon? That's the question. So we'll be switching over to the NASA live stream pretty soon. It just depends on when they decide to start. It looks like it's coming soon here, so I think we'll just switch over right now just to make sure that we're on the right page. All right. So obviously the NASA stream should start relatively soon. I haven't seen any updates so far about a change to the plan to land in roughly an hour and a half. So that means that our orbital insertion burn is going to start in about 10 minutes. So hopefully they're going to at least give us an update on that, but we will see. So yeah, how long does it take radio signals to get from the moon to Earth? So of course radio signals are traveling at the speed of light, because it's also a form of light. It takes about a second and a half. So there's obviously going to be a second and a half of delay automatically just because of that. So it's not like it's totally real time that we'll see, but it's basically as real time as you can get for space travel. I mean, if you were on like Mars or something, it would be like a 20-minute delay, and that would be, you know, a lot more significant. But for the moon, it's relatively instant. The real problem is the distance that you have to travel means that there's a large attenuation of the signal. So this is why I suspect we're probably not going to get 24 frames a second, you know, full HD of the lunar landing, because yeah, there is the longer things get apart, the less data you can transfer with the same size of an antenna. And putting a huge antenna onto a lander is obviously going to be really difficult. The size of that lander, by the way, is roughly the size of like a minivan. So it looks kind of small on the screen, but it's actually quite a bit larger.
First time in 52 years.
Nova C uses an environmentally-friendly mixture of liquid methane.
Here we go. We're actually starting the stream.
Incredibly challenging thing like landing on the moon forced us to innovate.
Intuitive Machines has built an entire space program to support these CLIPS missions. The company completed its lunar lander in a new facility at the Houston Spaceport, just down the street from NASA's Johnson Space Center. It's an autonomous Nova C class lunar lander named Odysseus.
Lunar lander arrived at Kennedy Space Center in
So
Florida
Odysseus
back in December.
is the name of the
Since
lander,
then, teams
in case
have
you were
been
wondering.
integrating the spacecraft to Falcon 9's second stage in preparation for launch.
And it did launch on a Falcon 9.
The Odysseus lunar lander.
Falcon 9 has
So,
successfully lifted off from
in my opinion, can they land it? Well, I think that they can. They've definitely put a lot of effort into it, and it's definitely probably the most professional lander that has launched so far, just to be completely honest. Like beyond the professionality of countries, of course. Like it's probably not quite as sophisticated as the Chandrayaan lander that we saw from India, but it's probably the most professional commercial lander that we've seen so far. So I have actually a lot of faith in it. And they're using a lot of cool like technology. Like the whole propulsion system is running on liquid oxygen and methane, which is definitely a step up from uh, fuels and oxidizers that they've used in the past.
Start the landing sequence for the IM-1 mission. Our mission and activity directors are sitting closest to the large monitor inside Nova Control, and they're supported by 10 additional flight controllers surrounding the circular Mission Operations Center. Good afternoon and welcome to our coverage of the descent and landing of the IM-1 mission. I'm Josh Marshall, Communications Director of Intuitive Machines.
And I'm Gary Jordan with NASA Communications. This mission is one of the first under a task order with NASA's Commercial Lunar Payload Services Initiative. Under Artemis, we're returning to the moon to conduct groundbreaking scientific discoveries and technological advancements. And this mission with Intuitive Machines is helping us to get there.
And Gary and I are at Intuitive Machines' facility here in Houston, just down the street from NASA's Johnson Space Center. Right now, inside Nova Control, flight controllers are monitoring our Nova C-class lunar lander named Odysseus ahead of its autonomous landing sequence that begins with powered descent initiation at 5:11 p.m. Central Time for a landing time at 5:24 p.m. Central. Right now, they're keeping an eye on the room's situational awareness tool called the Viz, which you can see on your screen now. The Viz is casted onto a large television in the front
So
of
this is
Mission
where
Control,
all our
so
updates on the
activity
telemetry is.
director and the mission director can have the best view, Gary.
And the Viz is an animation.
So we're about 10 minutes away from their next orbital maneuver, and we can see how that plays out just by looking at the screen here. They'll show us the altitude and speed data and things like that. So keep an eye on that for what's happening with the mission.
In space. The white line points to the moon. The blue line is the past and intended trajectory. The yellow and red lines are pointing towards the sun and Earth, respectively. The different color cones you see at the top are the antenna arrays used for line-of-sight communication back to Earth. We'll show the Viz periodically throughout our coverage, up to about 12 minutes prior to landing. In these final moments before landing, the most reliable spacecraft data will be relayed through Nova Control audio loops.
And we're starting our coverage later than expected today as flight controllers continue to assess Nova-C's trajectory, guidance, navigation, and control. Nova-C maintained a low lunar orbit, but is in a slightly more elliptical shape. Last night, flight controllers performed a lunar correction maneuver burn to adjust the lander's orbit. This burn kept Nova-C...
For how they figure out how far away it is, basically they're using the onboard communications stuff to do that. So basically, they can tell how far away it is from the ground station on Earth immediately just by communicating with it. They can tell that based on the length of time it takes for the signal to get there. That's a really reliable way to do range tracking and things like this. The satellite also is able to figure out how high it is above the surface just by using radar and LiDAR. I think when you're high up, you just use a radar signal, but then as they get closer to the ground, they need to kind of figure out and map out things that are around the vehicle. So that's when they switch over to things like LiDAR for more reliable data.
De-orbit initiation burn, which would have brought Nova-C from low lunar orbit into the descent phase. Nova-C's current trajectory has it continuing to decrease its altitude over the next hour until the braking burn called powered descent initiation.
Again, the landing time is expected at 5:24 p.m. Central Standard Time, 6:24 p.m. Eastern. The countdown clock at the top of your screen is counting down to the time that we expect to remove, and we expect to remove the countdown clock approximately 2 minutes before the landing opportunity. Getting to this moment, Gary, has been quite the journey, and it's lasted about 7 days so far since liftoff from Launch Complex 39A at NASA's Kennedy Space Center. Odysseus lifted off at 1:05 a.m. Eastern Standard Time from atop a SpaceX Falcon 9 rocket on February 15th.
So it took off about a week ago. Just so you know, it took them about a week to get to the moon and get themselves into the orbits they needed.
Shot at the moon. In the following days after launch, flight controllers in Nova Control commanded engine firings to place the lander into low lunar orbit approximately 100 kilometers or 62 miles above the lunar surface. The journey to low lunar orbit included firing the first liquid methane and liquid oxygen engine in space. This was called the commissioning maneuver. It was a full thrust main stage engine burn with a throttle down profile necessary to land on the moon.
That's technically not true. the Starship engine, which is also a methane and oxygen engine, did technically burn in space on its last attempts to get to orbit. They did get over the Kármán line, so technically it's not quite the first one to be tested in space. Technically, that honor does go to SpaceX and the Raptor engine.
On the lunar surface, carrying 12 payloads down with it. The mission is enabled under a task order with NASA's Commercial Lunar Payload Services, or CLPS. Here's more on this initiative under Artemis.
Yeah, nozzles do work in vacuum. They actually work a lot better in vacuum because basically the amount of efficiency that you have is based on how much pressure you're fighting against after the plume comes out of the nozzle. So if you have no pressure to fight against, the gases are able to expand to infinity, and you actually get the best efficiency that the nozzle is actually capable of. It's actually an atmosphere where you actually lose energy and lose specific impulse. So it's actually better to be in space a little bit.
We are enabling American companies to send our payloads to the lunar surface for us. These delivery services will expand our capabilities for exploration, radically increasing the amount of science we can achieve. This high-risk, high-reward initiative will invest in and leverage the entrepreneurial spirit of American innovation to launch a commercial lunar marketplace.
So there are three other companies, I think, that are also launching things to the moon. There's the Peregrine lander, there's Astrobiotics, and there's, I think, one other company that has contracts to land things to the moon for NASA. So it's a pretty big program, and they're trying to incentivize companies to try to build these things in order to allow NASA to be able to just pick people in the future to put payloads onto the moon, which is obviously a huge step if you want to establish a more permanent presence there.
To live on another world because we are explorers.
So a little more about the propellants they're using. Obviously, they're using liquid oxygen and methane, and keeping that cold is obviously a huge concern because in space you don't really have any shielding. The sun is just always beating down on you and heating up your cryogenic propellants. So they need to actually do some things to keep the liquid oxygen cooled so that they don't have a large boil-off rate.
Associate Administrator for Exploration. Thanks so much for being here, Joel.
Oh, thank you, Leah. It's great to be here on Landing Day, which is the culmination of about 5 years of work by Intuitive Machines Corporation.
Yeah, we're really excited, and we want to know a little bit more about NASA's goals for the CLPS initiative.
Okay. So, most basically what we want to do is we want to have American companies take NASA equipment and scientific investigations all the way to the surface of the moon and not have to have NASA do it.
Yeah, I'm hoping they're going to show the orbital deceleration burn here a little bit. I don't know if you can tell based on what the telemetry is showing us, but we should see them perform that pretty soon. Just to clarify on the point about rockets working in space, Newton's third law works anywhere, no matter where you are. So if you want to create a reaction, you just have to push in the opposite direction and shoot some mass away from you. You don't need to push against anything. As long as mass is leaving you, then you're accelerating yourself in the opposite direction. That's the idea of Newton's third law. So there's no need for like an atmosphere or the ground to push off of in order to create that.
For example, we will do science at the South Pole with our astronauts in Artemis and also with robotic explorers. They'll be brought down on CLPS. But we're also going to use these robotic landings, these commercial robotic landings, to do science at places where we won't initially.
It's actually exactly like a gun recoil. So basically the bullet gets shot out with really high velocity, but obviously there needs to be an opposite reaction, which is why you feel the pushback from the gun, because the gun is accelerating in the opposite direction.
Sending our astronauts in the future. That is, what type of dust or dirt is there? How hot or cold does it get? What's the radiation environment? These are all things you'd really like to know before you send the first human explorers. I'd also say that in the future, when we are flying humans to the moon as part of Artemis, we can use commercial services like CLPS to pre-stage equipment or other cargo so that it's there waiting for the astronaut explorers when they land.
And this is an entirely new approach that uses a privately developed lunar lander. What are some of the
So Brian, you're right. There actually is a very tiny atmosphere that surrounds the moon. It's not exactly a complete vacuum, but for all intents and purposes of flying in space in general, like the atmosphere is so thin that it's almost not really worth really worrying about. It would be equivalent to the amount of atmosphere that exists on Earth, but at an altitude of like a couple hundred kilometers. So at that point, you're technically in space, according to the to our standards for the Kármán line. So for that reason, we just say, yeah, it's a vacuum.
Has no air. You can't use parachutes or wings to slow down. You have to, in effect, ride a rocket engine all the way from orbital speed.
In terms of missions that are planned to use solar sails, there actually have been missions in the past that were using solar sails. They were just demonstrator concepts, so they just went into low Earth orbit and showed that you can use them in order to maneuver and things like this. I am not sure that you would use a solar sail for some types of missions. I think the best way that they would be useful would be going towards the sun. So if you're going to Mercury or going to Venus, I think that would be a really good application for a solar sail. But if you're going further out of the solar system, it's maybe not the greatest because the sun's not that strong.
An 11-minute braking burn that sets Nova-C up for the final moments prior to touchdown. That time of ignition for PDI, or powered descent initiation, is 5:11 p.m. Central Time, 6:11 p.m. Eastern. The entire landing sequence is autonomous, meaning the lander is in control of every milestone required for a lunar landing opportunity, Gary.
And completing a soft touchdown comes with challenges unique to, say, landing on the Earth or Mars, because there's no atmosphere.
Gary, it's an entirely different playbook as we've seen this dynamic situation play out today. Let's take a look at the IM-1 mission's complete trajectory approach as of launch. The Intuitive Machines IM-1 mission is sending commercial and NASA payloads to the lunar South Pole region on an uncrewed robotic Nova-C class lunar lander called Odysseus.
The lander is the tip of the iceberg, and what's below that is the full program that is on a miniature scale, very similar to what the Apollo program.
Yeah, if the audio on the live stream is a bit low, unfortunately that's as high as I can put it right now. I think the audio from them themselves is actually pretty low, but
is going to hit the moon 6 or 7 days later like an outfielder stretching out to grab it.
The first 4 days are dedicated to flight controllers in Houston firing the lander's 3D printed liquid methane.
But these methane engines that they're using, this is the first time it's been put onto any sort of lander that they would use something that is not hypergolic fuel. So that's kind of a big deal in terms of that.
Think about the B-plane, kind of like the backboard of a basketball ball. And you basically know when you shoot hoops that if you can get the basketball in the square on that backboard, it's going to go in. And the B-plane for astrodynamicists is very much the same thing.
With the B-plane on target, Odysseus is prepped for a critical autonomous maneuver on the moon's far side. This critical burn maneuver is completed in the blind, with the moon blocking direct communications back to Nova Control in Houston.
Once we get around the moon, we have on the day side of the moon, the sun heating us from one side and reflected infrared light off the bright moon warming us on the other. Then we plunge into night, and now we're cold on both sides. It's very tough.
About an hour before landing, flight controllers command Descent Orbit Insertion, or DOI. This is a main engine firing to slow the spacecraft so its altitude drops from 100 kilometers to about 10 kilometers above the lunar surface. After DOI, Odysseus coasts for about an hour before
So the next maneuver
starting its final approach.
The next maneuver is actually, I think, already happened. according to their timeline, they do a slight maneuver where they just lower the orbital the periapsis a little bit. The next insertion, sorry, the next deceleration burn will happen in, I think, about 50 minutes or so. That's basically where they're going to start scrubbing off a bunch of their velocity to try to get the lunar lander in position so that they can start their vertical descent. And that's going to take about 10 minutes.
Expect about a 15-second delay before confirming the ultimate milestone, softly landing on the surface of the moon.
And I can tell you just from doing our simulations, that's the longest 15 seconds you'll ever experience as you wait for the final light to turn green to indicate that you've landed on the moon.
Approximately 12 minutes before our landing opportunity, we're going to show this animation of the landing sequence to describe the lander's autonomous operations, starting with powered descent initiation, or PDI. During this maneuver, Odysseus must reduce its velocity by approximately 1,800 meters per second. You can think of it as a braking phase. Then, the lander pitches upright using its main engine with the Hazard Relative Navigation, or HRN, now being fed by NASA's NDL sensors, facing toward the area where the lander intends to touch down. At this point, HRN will autonomously scan the intended landing site for a safe landing area. Then, the lander's guidance, navigation, and control system commands Odysseus to a point approximately 30 meters above the designated landing site, and the lander goes into a vertical descent followed by terminal descent. Intuitive Machines created Nova-C for the CLIPS initiative and commercial enterprise with the goal of creating a lunar economy.
And Nova-C is Intuitive Machines' first autonomous spacecraft. Nova stands for new, and C is the Roman numeral for 100, the lander's approximate payload capacity. With that, let's learn more about the Nova-C class lunar lander.
This IM-1 mission lander is named Odysseus. The name was nominated by Assembly, Integration, and Test Engineer Mario Romero after the Odyssey and its epic voyage across the daunting, wine-dark sea. Including landing gear, Odysseus is 4.6 meters wide, and with its top-deck solar array, it's 4.3 meters in height. It's a taller design that accommodates payloads and the lunar South Pole lighting conditions. Its hull diameter is 1.6 meters.
The orbiter, sorry, the lander is actually a little bit sensitive to the orientation that it lands in. So it's actually going to be really important that they pick a landing spot that is relatively flat, which is why they have this system on board that's going to be basically telling them what the layout looks like just before they land, so they can pick a spot like where there's not like a boulder in the way or something.
Its final descent to the lunar surface in one continuous burn.
But that one Methalox engine that they have is the only engine that's on the vehicle, which is actually another semi-interesting thing about the lander. A lot of other commercial and also just landers that have been going to the moon recently usually have like, you know, up to 10, 15 thrusters on the vehicle, and they basically pulse them in order to try to get the lander to come down. But instead of that, they just use thrust vector control with one engine on this thing, I think. So it seems like it seems a bit simpler, but it's also a lot more dangerous, because basically if something goes wrong with that engine, like that's it. Game over. But I guess they have a lot of confidence in this engine. And if you remember, that's actually the way Apollo worked. They also only had one engine, and it was also thrust vector control. So yeah, guess going back to the old way.
Lose signal while Nova-C is on the far side of the moon. However, the trajectory of the lander's low lunar orbit does allow for near continuous.
There are cameras on board. They've been taking pictures quite a lot on the way from Earth to the moon, so they're definitely there. The question is, will they be showing them live or not? I hope they at least give us some live pictures once they confirm landing or something. And I'm sure we'll see maybe a little bit of a live video at some point. Although they probably won't release that live, I suspect. We'll see. It would be really nice if they did.
Space Network.
So when we first got onto the Commercial Lunar Payload Services contract, we were trying to find a way that we could get our data from our landers back to the...
So it's not going to be landing beside the Eagle lander, the Eagle landers. So we won't get a third party view. It's going to a completely different location, a new location that no one's ever been to yet, which is down by the South Pole. So it should be getting some new footage and some new interesting lunar topography. Also, maybe it might even see some ice. That's kind of what we're going there for in the first place. So that would be a huge mission success if they were able to find some evidence of ice that's just at the surface.
And what are the goals overall for Intuitive Machines? How do you want to expand this LDN coverage?
So we believe that as the market expands at lunar distance, many people will need the capability to send data back, particularly if you're operating spacecraft on the backside of the moon. You need to be able to have a relay satellite. So we're going to put relay satellites in orbit to complement our ground-based systems, which are, again, large dishes all over the world. And by doing that, we'll be able to hopefully create a market for that data system from lunar space.
Okay. Is there anything else that you want to share that has gone into the development of this network?
It's really exciting. We've actually been using it this week once we launched Odysseus into space, and we're taking it to the moon. We've been using this network that we tested with NASA systems for the whole week, and it's been incredible to see it work and see it in action. We have a long ways to go with it. We need to add additional satellites to the system so that we can relay data back from the moon. But we think it is the future of humanity in lunar space.
Thanks so much. It's really exciting to see.
Also, just to be clear, this is just a lander, so it's not actually going to take off and come back to Earth. So it's just a lander. It's just landing there to put stuff onto the surface, and that's it. Is it worth sending people into space when we have very capable robots? Well, that's actually a good question. We do have very capable robots and capable landers, but there is definitely a huge benefit to having people because they can do like 1,000 times more science in a given amount of time than a robot can. Like if you look at how slow things like the rovers on Mars explore the surface, like they'll move like 100 meters over the course of weeks. So if you had a human there, like that could probably go a lot faster.
Lander is on the far side of the moon, and green is on the near side. The line is the tail where Nova-C is, with each dot representing 10 minutes of elapsed time. The acceleration sensed portion of the screen shows raw acceleration values from Nova-C's inertial measurement unit. This is used a lot during burn maneuvers and is a more robust way of measuring acceleration over time with the ability to look back at what has happened. For some reason, flight controllers have lost data. Finally, the column on the right is a received, accepted, edited, and failed pre-checked, or RAFE chart for short. When each of these lines are on top of each other, that's a good indication that Nova-C's navigation system is in good health. That's because every measurement Nova-C makes must be received, accepted, edited, or failed pre-check. The failure is a possible outlier of data that the lander's computer automatically knows is bad information. Collectively, the DDL screen is one of many data displays that flight controllers are monitoring to successfully navigate Nova-C to the lunar surface.
Data visualization is an essential component for flight controllers who need to process this data.
So how much would a discovery of ice impact future lunar missions? Well, it would hugely impact human lunar missions because obviously we're going to go to where the ice is. It's basically gives us huge advantages in terms of keeping humans alive on the moon, but it also gives us advantages in terms of taking off and landing on the moon because it's also rocket fuel if you split it apart and turn it into hydrogen and oxygen. So if you have fuel on the moon, then obviously that's going to make it a lot easier to get there and get back because you can just refuel on the moon. Yeah, so the ice molecules are buried in the surface. It's not all over the moon. We suspect that it's mostly in craters that are on and near the poles. And the reason for that is that obviously the sun is coming from like the side of the planet. So at the poles, if you're inside of a crater, that as the moon spins, it's kind of always in the shadow of the crater. So that means that it never really gets heated by the sun. So it never gets the chance to heat up and evaporate. So you could have ice that stays there for, millions of years and never gets heated up. And that's why the concept is that you would find water, if it does exist, in these areas.
It's going to detect all kinds of radio emission that is falling on the moon. Right now it is close to solar maximum, so the sun is producing a lot of coronal mass ejections and radio emission associated with them. And we can detect these radio bursts from the sun. Characterization of the radio environment of the moon is very important. It has not been completely done, and therefore Rolls-Royce will be able to contribute in identifying various
so the concept of helium-3 as a resource that we could mine on the moon, it does exist on the moon, so mining it, of course, is great, but we actually need to have an industry that could accept the helium-3. Right now, we don't have fusion reactors that are, would be able to take that helium-3 and use it. So without that, there's kind of no way to sell it. So I don't think that's going to be something that's going to be huge in the near future. Unless we figure out fusion all of a sudden, then obviously that would be a huge market. This is an example on screen there. You see an example of the reflectors that they're putting onto the rover. Not the rover, sorry, the lander. It's going to basically go right on the solar panel there. And it allows you to shoot like a laser at it, and it'll like bounce right back at you.
The purpose is to have a precise fiducial marker on the landers. It serves as a landmark for future missions if you want to go back and land it there.
It also tells you how far it is away. So again, you can use the same method as you do
Stereo
with radar
cameras
to figure out how
for
far it is
lunar
away.
plume surface studies, or SCALPs, will use a suite of 4 cameras to capture stereo and still image data of the dust plume created by the lander's engine from when it begins its descent to the lunar surface all the way down through engine shutoff.
SCALPs is an array of small cameras.
So the whole dust thing is really important, because if you're coming down to the surface of the moon, there's a regolith layer, and if the engine is on as you land, it's going to create like this big huge plume of dust that goes up and over the vehicle. You can kind of see an animation of it there. That can be really scary, especially if you actually end up digging into the actual surface of the moon, because you could have things like shooting back up at your vehicle, which could obviously wreck your machines, destroy your legs, maybe even damage your tanks. So I think they're trying to figure out exactly what they're trying to collect some data as to what the magnitude of that dust plume will be when you make this landing. Also, I assume those 4 stereo cameras can also take some good photography of the lunar surface. So that's a nice little side thing that we should get out of that.
Radio frequency mass gauge, or RFMG, is a fuel gauge used to measure the amount of propellant in spacecraft tanks in a low-gravity space environment.
This is
Using
actually
sensor
what I'm most
technology,
excited for.
RFMG will measure the amount or mass of cryogenic propellant in Nova-C's fuel and oxidizer tanks, providing data that can help predict fuel usage on future missions.
I'm Greg Zimmerly, the principal investor.
So yes, they could just put the engines on top and or sticking out of the sides and kind of limit the amount of effect they have on the regolith layer. But I think that maybe that's not necessarily the most ideal configuration in terms of center of mass and center of lift for the vehicle. Also, you can't just have one engine then, because if you put them on the sides, you need to, if you just have one, obviously that's out of balance. So you need to at least have 2. And most likely in those types of configurations, you'd have something like 3 or 4 engines, which obviously increases the complexity of the vehicle. So if you can do it with just an engine on the bottom, and that's a really reliable engine, and that's not going to be a problem for the regolith, I think that's probably the best way to proceed.
Doppler LiDAR, or NDL, and the Lunar Node 1, or LN1, later during our broadcast.
But just to say a little bit more about that experiment they're using for the measuring the level in a tank. If you just imagine how we usually measure levels in a tank, like usually you just have like a level sensor that floats on the fluid, and as the fluid goes down, the float goes down, and you can basically tell how much fluid is in the tank by just doing that. There's also other ways where you're just looking at like what the level of the fluid is to figure out what the tank is, how much stuff there's in the tank. But obviously, this all has the problem that you need it to be in gravity in order to figure out how much fluid you have. So the reason why this is interesting is because then maybe they can figure out a way to accurately measure how much liquid is in the propellant tank when it's just floating in space. Which, if you are, flying to and from a space station, maybe going down to the lunar surface, is probably going to be a little more important because you're spending most of your time in 0G. And with things like boil off, and if you don't really know exactly what your boil off rate is, that's obviously a really important number to know. Otherwise, you could run into a situation where you run out of fuel. So if you can figure out without gravity or without acceleration how much fuel is in the tank, that's obviously really important if you want to achieve a landing.
Just NASA as a sole customer. NASA's CLIPS initiative encourages a model where NASA is just one of many customers. And this is an important element to ensure that this model of transporting incredible science and technology instruments to the lunar surface is a sustainable and robust one.
Well, it's important, and Gary, it's also promising in this situation. The commercial interest for delivering science and technology demonstrations continues to grow. As of our third planned mission, we're seeing more and more non-CLIPS payloads from both domestic and international companies and institutions, which are driving us towards a future, maybe completely commercial mission to the moon, possibly as soon as our fourth mission.
Well, even on IM-1, there is a variety of unique commercial payloads. It's a good snapshot of out-of-the-box ways to think about what the moon can offer.
Well, that's part of the challenge. Beyond just creating the capability to land on the moon safely, we had to look toward a new emerging ideas and find innovative ways that may add value on Earth and spaceflight. Let's learn a little bit more.
So just for people that are joining just recently here, we are 50 minutes away from the scheduled touchdown. They will begin the descent burn in about 35 minutes or so. So basically they'll light up that engine and they'll start their scrubbing off the velocity that they need in order to come to nearly a stop just above the lunar surface, about 300, 400 meters above the surface. And then they're going to begin vertical descent where they pick their landing spot and come down and hopefully achieve a soft landing. So, question, can someone hack the cameras? That's actually happened before. Somebody managed to hack, I think, SpaceX's cameras on the Falcon 9. And they actually were able to switch to a lot of their engineering cameras, like things like inside the propellant tanks and around the vehicle. So it's not just the standard camera views that you see in the live streams. So I'm sure it's possible you could hack the cameras on board the vehicle. But yeah, if you do, you might get a visit from from some officials. So maybe you don't want to do that. That being said, this is a commercial mission, so I guess there's no defense part of this. But still, you shouldn't hack cameras. That's not cool.
Where they would take these certifications,
I also suspect that the cameras themselves will not be streaming during the landing because they need to, like, their primary objective is to get the engineering data. Because, like, if something goes wrong and the lander crashes or they lose contact or something like that, they need to figure out why that happened. So they're going to be transmitting like all their acceleration data, all their range and sensing data. You saw the screen that had all of their sensors and stuff, and all that they were all, giving their live readings from the vehicle. So like that's the data they care about. So the actual camera data might not be so important. So that might be on like a delay, because they have limited bandwidth, so they can't send everything all at once. So keep that in mind. Even if you did hack the camera, you still might not get any data. So what do I think about using the lunar regolith for sintering structures together in situ? I think that's really cool. I think that maybe there might be also possibilities for like making some sort of lunar concrete like because the surface, like the surface of the moon, is made out of a lot of the same materials as are on Earth. So I could imagine you could probably make some sort of lunar concrete, and that might actually be easier to work with than trying to like extract metals out of the surface to put stuff together. But yeah, that depends on the technologies you send there and what we decide to develop. So have humans navigated to the moon since Apollo? Have we actually physically gone back? Well, lots of countries have sent landers to the moon since Apollo. So most notably would be obviously China, Japan, and India, and they've all sent lunar landers like in the past couple of years actually. China now has a very consistent program of sending probes and landers and rovers to the moon. And Japan and India, I think, have both sent one payload to the moon successfully. India has a very, I think they have a program which will keep going with Chandrayaan. So we should see some more interesting landings from them as well. But beyond that, there are no companies which have gone to the moon, and no humans have gone to the moon yet either. But that should all change soon because the idea is that Artemis will be sending humans to the moon in 2026. So that used to be 2024. So they do keep kind of pushing the date back, but I'm hoping before 2030 it happens at least.
I'm used to over at the International Space Station Flight Control Room, where you have consoles that are facing towards large screens. What exactly is the logic behind this particular design?
Really, we wanted to get everybody together into where we're a small company. There's not a lot of us. Agility is our strong suit in this situation.
You're looking at the Intuitive
Machines. Really
Machines.
Suited us.
You're looking at the Intuitive Machines control room right now. This is where they're basically receiving all of the data and keeping track of what's going on in the mission. At this point, I believe they're basically outside of the ability to control it with human hands. So it's basically all on automatic now. It's going to go into its deceleration burn automatically and hopefully achieve a soft landing. So the humans are not controlling it at this point anymore. It's not like Kerbal Space Program where you have to like manually land the rocket. If that was the case, I think it would be a lot more difficult.
This is Blue Team. That is Dr. Tim Crane. He's our co-founder and chief technology officer, serving as mission director.
Yeah. So if you wanna find us after this live stream, we do. This is all part of our YouTube channel. I'm part of a student rocketry group, so we are also building things, hopefully for space. We're trying to build a rocket which goes to space, and we put a lot of our progress and what we're up to and our interesting ideas on there. So sometimes it can be a bit entertaining. So do check us out.
Great to be here. Now tell me a little bit about this landing site. Why was it chosen? What sets it apart?
So the most important factor when selecting the landing site was to find a good, safe site for Odysseus to land, and we're landing in highland terrain near the poles, and that was a fun challenge for the team. But we think we found.
So in terms of how they picked the poor guy who had to stay in the command module back in the Apollo era, this was mostly just to do with the job that you had. So each of the three astronauts had a position that they were responsible for. So one person was the commander, and one person had to stay in the capsule that was orbiting the moon, obviously, because they had to do a redocking. Now, I imagine that you might feel like, oh man, I went all the way to the moon and I just got to float around in the spacecraft for like a day or two and wait for the guys to come back. But some of them actually expressed a little bit of a novel experience that they had while they were doing that, because obviously they were uniquely alone. There's no person in the world that's ever been that alone as those people were. So yeah, if you talk to some of them, it's actually a little bit of an interesting position that they were in.
The highlands near the poles, and so we have one of our instruments, for example, is SCALPS, and NASA likes its acronym. So it's the stereo camera for lunar plume studies, and so that camera, which is 4 video cameras, will image the dust.
So what's my opinion on the UFO situation? Well, I would suggest that maybe the amount of evidence that we have for UFOs being aliens is not very high. There are definitely lots of unidentified flying objects, though. Like, it's been that way for probably hundreds of years. Like, all kinds of weird stuff is in the sky. And a lot of it we don't understand. And the reason for that is we haven't really been in the sky that long. And we certainly haven't been in space that long. So I think there's going to be lots of weird phenomenon that will be happening when you're just going out there and seeing stuff. The trick is to try to figure out what it all is. I suspect that most of it is probably not to do with aliens. In almost all cases, there will be some sort of natural or human phenomenon that is causing those things. Yeah. If you look at like the history of astrology, sorry, not astrology, astronomy, there's been many instances where people thought, oh, it's aliens. But then after they do a little bit of, more research and more data, they realize, oh, this is actually a phenomenon, and oh, this is actually quite interesting. Yeah, a good example of that would be like pulsars or something, which everyone thought was aliens at first.
Malapert A is a fascinating satellite crater to Malapert, a crater only 300 kilometers from the moon's south pole. The site is named after Charles Malapert, a 17th century Belgium astronomer. The area
So we shouldn't have any issues with radiation messing with the mission, because they do use radiation-hardened electronics on this vehicle. That just means that they use a bunch of like shielding and redundancy, and they have some fancy ways inside of the electronics themselves to stop things like bit flips and latch ups and things like this from happening. So usually that makes them pretty reliable to the point where we shouldn't have this issue anymore. That being said, you never know. There could be like an extreme radiation situation that would cause there to be a problem. But I don't think there's any solar flares scheduled for the mission, so we shouldn't see that issue.
And Gary, we were originally targeting from NASA Oceanus Procellarum. It was a lunar mare in the region of the near side of the moon. The decision to move from the original landing site in Oceanus Procellarum was based on the need to learn more about terrain communications near the lunar south pole, which is expected to be made up of some of the best locations for sustained human presence on the moon. Landing near Malapert A also will help mission planners.
So in terms of how they managed to fit the lunar rovers for Apollo into the Apollo capsule, they actually had a lot of extra payload capacity on the Apollo missions. So yeah, they obviously wanted to take advantage of that. It's also important to note that on the descent stage that went down to the moon, they didn't take that back up to the Apollo capsule. So basically they could leave all that weight on the moon and win on the delta V equation. So it actually lets you land with a lot more weight than you would expect, because they're taking off with just the command module, or not. Yeah, so it's more of a volume situation. That's what surprised me. Like, how do they find the volume on the spacecraft to get a rover in there? That's kind of crazy to think about, I guess.
Orbit, flight controllers have been loading software patches and resetting the lander's guidance, navigation, and control system to use 2 laser beams.
Yeah, it was basically like an origami go-kart. That was an electric origami lunar go-kart. Yeah. And it's important to note also that it was operating in lunar gravity, which means that you don't actually need the same strength that a regular car would have on Earth. Everything is 1/6 of a G, so basically you can make things a lot more flimsy and get away with it, which was kind of, the way that those rovers worked. If they were operating on the Earth, they wouldn't have worked. Simple as that.
Flown there safely and landed there precisely. So the landing phase of that task is one of the most critical aspects of it. NDL is a LiDAR instrument that is used to enable that capability.
So you wouldn't actually see footage of them taking the rovers out of the LEM, and that's because the astronauts themselves had to operate the cameras. And obviously, it probably took 2 of them to get it out of there, so I don't expect you would ever have any footage of that. This was actually a really big drawback of the whole Apollo program in general, which is that they only had 2 people on the moon at once, and there's only so much you can do with just 2 people. It would be nice to have like a whole team of people, like maybe like 8 people, and then you can probably do a lot more, and you would have the capacity to maybe have somebody who's, you know, always operating a camera, always checking out what's going on. I think that would be a lot more interesting. So yeah, in terms of the feed right now, we don't really have a live like camera on the vehicle, but they do put up the telemetry screen every once in a while, so it tells us where the mission is. I suspect they're going to go to a more permanent broadcast of that and maybe even show us some pictures live, I'm not sure, once the descent burn starts. And to be clear, that descent burn is going to be starting in about 20 minutes, I believe. Maybe just over 20 minutes. So it is coming down to the nail-biting time, I would say. At this point, the lander is out of human control, and it is going to be operating completely autonomously. So it's in the lander's hands now.
And so we're looking to develop newer capabilities that we can do that more precisely, and that take up less volume and mass on the spacecraft, so that you can have all the available.
So the LEM was pressurized. They didn't have to wear spacesuits in it, but obviously once they got down to the surface and they started to do some lunar exploration, it was actually a lot easier for them to operate just by keeping the LEM depressurized. So they would actually sleep in the LEM, but with their suits on, which was like kind of weird. But yeah, it was actually a real problem because obviously when they had their suits on and they went into the LEM, the suits would have a whole bunch of dust on them and stuff, and that dust would get all over the capsule, which was really frustrating and annoying. But yeah, the LEM could be pressurized or depressurized. Either way, it could operate in both situations. But as they descended, it was definitely pressurized.
We would really like to know is what how the pulse comes back after they send a laser, and how it reflects back to the system, how long it takes to process, and how it will help define the solution to figure out the trajectory.
So that's a good question. If the Apollo had a live feed 52 years ago, why not now? Well, the physics of live feeds has not changed, so let's keep that in mind. We're still using the same technology, basically. We're still just using radio waves to send back the signal to the Earth. And just the physics of that prevents you from packing more data into that unless you're operating on different frequencies. So that being said, the live feed that was available 52 years ago was actually quite kind of terrible. It was very low resolution and probably wouldn't pass for the standards of today's video. However, that being said, I think the real reason why they usually don't want to show live feeds of these landings and things is because it's being done by a private company, and they don't want the bad PR if it goes wrong. So if they show the live view of the lander just like crashing into the moon, that might not do so well for the investors and stuff. So usually they're not so keen to show the live feed. If the lander is from a country or something, usually they're a little more excited to show the live feed because, you know, it's tied in with like nationalism and stuff. But yeah, I don't know. Personally, I think that all press is good press. So even if you did crash and showed the live feed, I think that's actually really positive. But that's just my opinion. I might be a little bit biased.
It floats, and so how can we do that so we know how much propellant there really is? And then the other one is scalps. One of the things that as it lands, the thrust is going to throw up all this ejecta of the
Who's paying me? Unfortunately, nobody. I wish someone was paying me. Yeah, Astra's always looking for money, so unfortunately no one's paying us yet.
To improve future landings to make them more safer.
Well, thank you so much, Prasanth. It's really been great speaking with you, really exciting stuff. And for now, we're going to send it back to Gary and Josh.
So there's actually, unfortunately, no rover on the lander. It's just a lander. It does have a bunch of payloads on it that they were mentioning about before, that are going to do a little bit of science once they land. But this particular lander is not planned to have any rovers on it. It will operate on the moon for about 14 days, That's the length of the lunar daytime. Once the moon goes to night in that section, obviously there's no sun to power the electronics, so it'll basically just die. So it's only designed to operate for about 14 days. Although I am curious if maybe it might just be able to survive the night and turn back on and once the next day comes, but it's not designed to do that because it does get quite cold. It goes down to like minus 100 Celsius, so that's like pretty bad for batteries and stuff, and usually it tends to stop things from working.
Ordinarily, when NASA delivers a payload to the surface of the moon, they do it with a commercial partner, but NASA controls the building of the vehicle. Now, we're buying the service of delivery of our lunar payloads
So
to the surface of the moon.
if this thing does land, it is going to be the first private mission that will get to the moon. So it's a pretty cool mission.
They decide how to get it to the moon. They have to develop their own lander, but they also have to manage the entire end-to-end mission.
It's meant to provide affordable, rapid, frequent access to the lunar surface through American companies.
We're funding different companies.
We have commercial companies that are competing to win task orders to deliver our payloads to the surface of the moon.
One of the goals when we started CLIPS was to help
So is there any AI involved in the computer systems? There definitely is. That whole system that's used to actually calculate at a spot where the lander will land in the end, there is not an actual like coordinates to the meter landing spot that they've selected. They've kind of selected a landing zone, and then once the lander gets within a couple hundred meters from the surface, it's going to basically map out that region and decide where the best spot to land is. So that all requires a little bit of like computer image processing and stuff like this. So there is AI built into that part of it. It's kind of like the same sort of systems that are involved in a self-driving car. So it's like a self-flying probe, which would, has the same kind of idea as a self-driving car. It has to identify the boulders, has to identify, oh, that's a crater, that's a weird angle over there. That's the flat spot, and then it will try to fly towards the flat spot so it can make the proper landing. And for this one, it's actually really important because if you've seen the pictures of it, it's kind of a tall lander, so it doesn't have a very good very low center of mass. So if it is at a weird angle, it does run the risk of tipping over. So it's really important that system works. So the orbital speed for the moon, that is about 1.6 kilometers a second, at least for the orbit that they're in. So that's how much velocity they have to scrub off before they're able to do this landing. So that's why the landing burn takes like just over 10 minutes. So that's how long it takes for them to actually decelerate the spacecraft to the point where they can do that proper vertical landing. So we've not been able to make a suit that is to withstand the radiation in outer space. That's kind of true, not for a long period of time anyway. We have, spacecraft do have radiation shielding though. So for instance, on the International Space Station, they have sections within the station that are shielded. It's mostly shielded by water and poop, by the way. It turns out that actually works as a great shield. So if there is a solar storm, the astronauts will all go into those areas so that they don't get as high of a radiation dose.
Thank you, Gary. I'm joined now by Jim Free, NASA's Associate Administrator. Thank you for joining us, Jim.
Thanks for having me.
This is a big day, and what are some of the challenges to landing on the moon that people might not expect?
Well, it is a big day, by the way. You're right. I think the challenges are multifaceted. First, getting into lunar orbit is a challenge. Going to the South Pole is different than going to other parts of the lunar surface. The lighting conditions are a lot different than at the equator. So you have your hazard detection.
So in terms of people going to space, basically Apollo's the only program which sent people beyond low Earth orbit. There have been, I believe, the Axiom mission went above 400 miles though. It went up to something like 800 miles or something. So there have been people who have gone a little bit higher, but that's still technically low Earth orbit. So For all intents and purposes, the only time anyone's ever left the sphere of influence of the Earth was during the Apollo program. But we're hoping that's going to change, though, because America now does have the capability with SLS to send people beyond Earth's influence again. Of course, that's just going back to the moon, but it will be good to see the program expanding. And this is part of it, because what enables Artemis to happen is if commercial companies are able to get payloads to the moon. That's going to be what resupplies people that go to the moon. That's going to be what sends maybe experiments to go to the moon. And maybe some technologies where we try to experiment with, building stuff on the moon, things like that. And especially figuring out if there's ice there. So this is all part of that mission, which is to take humans, hopefully, further away from Earth and get us exploring the solar system a bit.
Where we spurred on investment in commercial delivery of cargo to a space station, that's ported over into our crews flying commercially. We're doing that on the Artemis program, buying things by service so that we can spur on other investment that allows us to get our resources and use them elsewhere to do other parts of our mission, exploring the moon or beyond.
You talked a little bit about Artemis for a second. So how does CLIPS fold into NASA's plans with Artemis and with this Moon to Mars architecture?
I think I could talk about Artemis for hours.
Me too.
But CLIPS is absolutely essential for Artemis. It's our first.
So unfortunately, we don't have a live feed right now of the spacecraft. We're just getting the live feed of the operations room. This is the Intuitive Machines operations room because this is operated fully by Intuitive Machines. They're just doing a contract for NASA, but it's the vehicle is Intuitive Machines. And yes, they usually private companies don't like to live stream activities that could affect their stock price. or cause their investors to lose faith in the program. So, but I expect they will give us a little bit of, they'll give us telemetry data and things like that. They had a whole screen that they showed us before that had like all the acceleration and velocity and all kinds of different sensor data that is there to tell us how the vehicle is performing. So I expect they will show us that once their deceleration maneuvers start. To be clear, that starts up in about 12 minutes. They'll start their deceleration burns, which will take them just over the landing spot. The touchdown is planned for 26 minutes from now. And you can see the clock that is showing the time to the touchdown in the top of the screen. So that'll let you know how far we are away from that.
Experiment that integrates navigation and communication functionality for autonomous navigation to support.
So just to answer your question here, for something that comes back from the moon, what's the speed in miles per hour? So when you're coming back from the moon, it depends on what you're measuring relative to, but I assume you mean relative to the Earth. If you're coming back from the moon, usually you get up to a speed of around 40,000 miles per hour. So it is quite fast. It depends though on like the steepness of your reentry, because you can come back obviously a lot faster. That's basically the speed that they were flying at when they were coming back from Apollo. If you were coming back maybe in a more gentle way, so using a Hohmann transfer instead of just the what was the maneuver they called that they were on? They were on a free return trajectory, so it's actually one that has a little bit more energy than a Hohmann transfer. But on that one, obviously you have a lot more speed. Usually when you come back from the moon, you would come back on that kind of trajectory because it's not really that much more delta V inefficient, but you can save a lot of time.
Technology can support a network of communication and navigation amongst local surface and orbital operations. LN-1 will test multiple navigation links from the surface of the moon back to Earth to characterize both maps transfers as well as GPS-like signals that could support a future lunar communication and navigation network.
Gary, one of the best things about communication and data is getting imagery back. And Intuitive Machines has several camera systems on board, including Eagle Cam. Cam. It started as a challenge from our CEO,
Now, if only
Steve
they would
Altemus,
live
to his
stream those
alma
video
mater,
cameras, that'd be great.
Embry-Riddle Aeronautical University. Students and faculty created Eagle Cam to take an out-of-this-world selfie of Odysseus landing on the moon. The camera system could capture the world's first ever third-person picture of a spacecraft making an extraterrestrial landing. The camera system is designed to deploy off of Nova C approximately 30 meters above the lunar surface and take images of Odysseus during landing. Additionally, the
So this
device
is
will
gonna be
test
really
a
interesting.
dust removal system, which could lead to the future advances in spacesuit technology. As part of this project for Eagle Cam, Embry-Riddle teamed up with NASA's Kennedy Space Center to demonstrate the NASA-developed electrodynamic dust shield, or EDS. EDS uses an electric field to remove dust. The technology was tested aboard the International Space Station and will be the first ever demonstration of EDS technology on the lunar surface after.
So it looks like they're actually going to maybe deploy a camera before the landing. They perform the landing. So I'm pretty sure they will not live stream that. If they did, that would be amazing. But that means that they will have video afterwards of the lunar lander coming down for the whole vertical phase, which will definitely be pretty cool.
5 quick images every 5 minutes for 2 hours, starting 100 seconds after separating from SpaceX's second stage. Out of all of those images that were taken, we ended up with just 4 inspiring ones to show humanity's place in the universe. And right now, we're a little more than 10 minutes from powered descent initiation. Let's go to Leah Cheshire one last time for the final interview ahead of this critical maneuver. Leah?
Thanks, John.
So we're just coming up on the final stages of the deceleration here. They're almost in the spot where they're almost halfway around the moon again, in the spot where they're going to start the deceleration burn. And I'm hoping they're going to switch to the operations room with the live telemetry, at least, while that occurs. Yeah, so the movie with Tom Cruise going to the ISS, I'm not sure if that's still happening. Is that still in the cards? I feel like that was supposed to happen a while ago. I think it would be really cool if film companies start realizing that, hey, it's actually cheaper to just go film on location in space, and we can get some more real feeling space movies. I think that'd be something that'd be really cool to come out of this.
So we are working with these American companies in a very unique way. These are challenging goals, and some people would probably consider this a bold endeavor. But what does it mean to you?
Yeah, I am not sure how much of the descent they will show, but I suspect they will not live stream that as it happens. Yeah, we have to also keep in mind, for the reasons as why they don't do this, the space restrictions that are on the vehicle itself. Like on the Apollo capsules, the Apollo capsule was huge in terms of space in general. So, like getting some telemetry and communications modules on that can communicate the distance all the way back to Earth is actually not as hard, because you can just put a bigger antenna on it. But on these little landers that are going to the moon right now, putting a big communications array onto it is actually quite mass intensive, and sometimes is a little bit kills the mission. So you don't get as much data back per second as you might have got back for some bigger payloads that have landed on the moon.
Do on the moon, particularly where this one is going down to the South Pole. We think we're going to find great volatiles down there. So as we get prepared
Volatiles
to
means
send
water.
Astronauts there, then we know that there's water there, and we can use that water. Water's very heavy to carry, so it's really great if you can use it on the moon. We can break it up into hydrogen and oxygen, use it for fuel. Really great for our sustainability, but also the
So how do they slow something traveling at 40,000 miles per hour when it arrives back to Earth? Well, basically the only way to do it with any sort of mass efficiency is, of course, to just use the atmosphere. Yeah, it's basically like it's very available and it's there to use. So obviously that's pretty much the only way you can do it. You have to make sure though that you actually have the thermal resistance in order to protect your spacecraft from the heating that you get from that, because obviously that energy has to go somewhere, and what it goes into is heating. So that's why it's really important to have heat shields. The Apollo heat shield was some pretty insane stuff. It had to take a lot of beating. And there's also a lot of new space heat shields that they're experimenting with. So like even just with SpaceX, like they have these like hexagonal tiles that they're using now, which are supposed to be more reusable. If you looked at the Apollo heat shield, it was totally like you couldn't reuse it. Like it was one use. It just burns away and ablates, which is a really good method to use as a heat shield. But if you're trying to reuse spacecraft, obviously that's not going to work very well. So yeah, there's definitely more going into the reusability of those now, so that you can achieve better ways to aerobrake. That's what it's called when you use the atmosphere, aerobraking.
Standing by for powered descent initiation. Gary, this is a critical 11-minute burn to slow the lateral velocity such that Nova-C can pitch over for further operations. And while we were in that interview, we did hear that the main engine gimbal checkout was completed. So now we're focused on the operations with Nova Control. For folks at home, we are listening in to the live channel there.
That's right. A lot's happening in Nova Control. We're going to be hearing these status calls periodically as we follow the flight control teams that are monitoring Nova-C's descent towards the lunar surface. A lot's happening, Josh. Of course, we have this 11-minute burn. We're focused on the propulsion elements of this PDI. At the same time, the spacecraft is oriented in such a way that it can use a technology called terrain relative navigation to scan the environment along the way. What's happening there?
Right, so we know that we needed terrain relative.
So a water-cooled heat shield, although sounds good in concept, the heating we're talking about is like thousands of degrees Celsius. So water is no longer a liquid at that temperature. Basically, you have to find materials that can bleed off more energy than that. And you either need something that can resist those temperatures, which is where you get the ceramic tiles, or you need something that will burn and physically be destroyed and removed from the vehicle. And that's the ablative heat shield material. But yeah, let's listen in a bit more to the callouts here, because we're going to start seeing some of the key mission phases here happening.
Beginning processing optical images, and that was nominal. The last time we heard that was just about 20 minutes ago.
The status checkouts of these critical systems are essential to understanding the performance. The folks you see now on your view, this is Nova Control. They're monitoring every step and all the data coming from Nova-C ahead of PDI, which is scheduled just a little bit after 5:11 p.m. Central Time. Exactly what are these folks looking at, Josh?
Well, right now everyone's looking at their assigned screens, and all of them are tailor-made. Generally, there's a few who are looking at the same type of screen, but they're tailor-made for their task. You have Spark looking at electronics, things like how hot are the electronics. Payloads are monitoring different parts and pieces.
5 degrees to burn attitude.
5 degrees left until burn attitude. The vehicle's still getting ready for this PDI ignition, which we expect here in just about 2 minutes, Gary. Two minutes. So everyone's looking at their screens and doing their respective jobs and reporting up into the mission director, while the activity director is keeping in touch with everybody and making sure we're putting this whole thing together.
Press started.
There's a call for tank press started just a little bit before that, Gary. We did hear that they were working on the cryo fill. So these are all steps that are leading towards PDI, powered descent initiation. We expect that to take about 11 minutes, where we're slowing.
They have an external pressurization so that they can push the fluids into the combustion chamber.
In just a few minutes.
90 seconds to take.
Propellant tanks at flight pressure.
All right, 90 seconds until we begin that propulsive.
And this is actually a lot, very similar to how student groups power their rockets. So it's actually a really clever way to just pressure feed the engines.
This is a single continuous burn. After that, we're going to see a lot of events in rapid succession: pitch over, vertical, and terminal descent.
So this burn's
And we
going
just
to be
heard
about
another
11
call out
minutes.
from the prop console saying that feed line prep is complete. What that means is Nova Sea's propulsion system, that mixture of liquid methane and liquid oxygen, that feed line is prepped, getting ready to go into an injector to blend those two propellants, and the propellant and the oxidizer, and have ignition of PDI. We're tracking that in just under a minute, Gary.
Hopefully no stuck valves.
Converging on burn attitude.
Lander is getting into the correct attitude required.
Feed line prep complete, both sides.
Another call for feed line prep complete for liquid methane and liquid oxygen in preparation for this PDI burn.
I'm pretty sure they're just using helium to pressurize the tanks. So it's not a piston, it's actually they push a gas into the tank to pressurize it. And that's contained in like a third
15
tank.
seconds, exec mode.
The 15 seconds to exec mode. We're tracking a little less than a minute, though, until the time of ignition for power descent initiation.
Okay.
Settling. Ignition. Throttling up.
Yeah, confirmation of
Main stage.
ignition.
There we heard main stage ignition. That's coming from our prop console, Rob
Good
Moorhead.
control.
And they're
GNC
also
call on good
Full
control.
Thrust to weight 1.5.
And that thruster weight is, I think, a lunar thruster weight, not.
These are great call outs in between our prop console and our flight manager, Scott Tamblin, calling it as the data is feeding into the lander, which means we are continuing to have good communications. The lander is sending that back to flight controllers in Nova Control. Gary, something we prepared for, we planned on, is that loss of communications. And that's why we have this.
I see good thrust control.
It's a good thrust control call from prop, but that's why we have this autonomous lunar lander. You know, we program, we know that, hey, we want to light PDI in this moment. These are the steps you need to get there. But from here in, this is an autonomous lunar lander, and flight controllers are monitoring communications and tracking the progress right along with the public right now with us.
Nova Sea has the helm. It is in control and is making the decisions necessary to ensure a soft landing. We heard call-outs about thrust, full thrust right now. There is the ability to throttle that thrust, and we'll see that throughout the descent as the fuel tanks continue to unload and we expel that propellant.
So the lunar lander is all autonomous right now. It's just.
And we did
coming
have
down
a
on
few
its own.
questions come in about how much gas are we giving this to slow down the vehicle. And we want to remind folks that this PDI burn goes
Commanded thrust 90%.
goes in just about 90%, right on time. So it goes in at 90% in order to, if the lander makes a decision and says, I need to slow down more and make a decision to make a safe landing, it's able to add a little bit more oomph and make that decision a reality rather than just a possibility.
So this is all controlled via the avionics. It's got basically
I'm
its own
showing
brain.
500 kilometers to target, but my display's a little bit stale.
That's the mission director, Tim Crane, calling about 500 kilometers, but stating that his information might be just a bit stale.
1,000 PSI in the helium tank.
It's part of the reason we're showing this animation, Josh. Of course, this is not telemetry driven. We're just showing you exactly what's happening. As we hear the calls, this information is relayed through the audio loops. Not enough bandwidth to do a live stream of this, so we're relying on the data that's being fed from Nova Sea to Nova Control.
Yeah, that data is going into the flight controllers, and what you're seeing on your screen right now is just to give you an idea of the vehicle's attitude. You heard them talking about moving to a burn attitude. This is what we expect Nova Sea is doing right now. It is a simulation in the large screen just to give you an idea of what's happening over these critical approximate 10, 11 minutes of PDI, powered descent initiation, trying to slow Nova Sea down, bring that acceleration down to about 1,800 meters per second. And there's some follow-on steps after that, Gary. It involves pitching over the lander using that gimbaled engine. We heard the maneuver to burn attitude followed by main engine gimbal checkout. So they'll use that gimbal to pitch the lander over and start a vertical descent. This is where we start getting a little tricky as far as there is a final approach. It may add a few seconds, it may add a little bit of time, but we are intended to land right around 17:24. That's 5:24 p.m. Central Time. But know that there is some give and take. We're also expecting, plan for, and train for a little bit of loss of communication during this process.
That's right. And that communication is absolutely...
So the burn is so long because of the rocket itself is actually pretty weak compared to the weight of the vehicle. it only has a thrust to weight of 1.5 in lunar gravity, which would only be, I think, 0.3 or so on the Earth. So if you just set it on the Earth and fired the engine, it couldn't actually lift itself off the ground. But of course, you don't need a big, powerful engine when you go to the moon. You just need to have more thrust than the weight of the vehicle on the lunar surface. So when you're decelerating, it takes obviously a lot longer. So even though it just has 1.6 kilometers a second of velocity to shed, it takes a lot longer to get that velocity off. So yeah, we still have about 6 minutes or so, seven minutes or so left in the burn, and then we'll be into that vertical phase.
That was coming from FIDO and Flight Dynamics. Sean Stewart working the console this evening.
This is excellent calls to hear. Hazard relative navigation is going to be used after the pitch-over maneuver. This allows Nova C to make some decisions and scan the landing site underneath it and make decisions in an area that...
So this pitch-over maneuver that they keep talking about, so basically as they're, right now they're decelerating, but they're basically decelerating horizontal to the surface. So the vehicle is like sideways compared to the surface. But once they get most of their horizontal velocity scrubbed, then the vehicle will start just falling in the lunar gravity, and then the vehicle is going to pitch over and be standing vertical in order for the final descent sequence. So that's kind of what they mean by this pitch over maneuver.
Great call out to hear about the HRN camera system and processing those images. Right now I am tracking 5:16 p.m. We expect PDI to go until about 5:21, 5:22.
300 seconds and breaking one.
Or about 300 seconds to approximate those numbers.
Very precise.
So 5 minutes away until this engine stops burning, at least for the main descent part of it. Once they get out of this phase, they'll just be coming down straight vertical to the surface, and they will probably do some pauses as they go through that process. So how do they test this maneuver? You can't. This is all, like, the way that they plan this, it's all done in, they do like hardware in the loop tests and stuff like this. Obviously there is no lunar gravity on Earth, so you can't like test this before you get to the moon. This is the test.
Engine as well as the helium tank. So what we haven't mentioned so far in the show is that the helium tank pressurizes that liquid methane and liquid oxygen tank, but in addition it's also used for reaction control system. Those are the small spurts that you see at the top of the lander in the animation that control the vehicle's attitude. So for things like landing on the moon, you really want to land at the right attitude. That way your antennas are facing back, direct line of sight to Earth, and you can get that ultimate confirmation once you do suspect that you have landed on the moon.
The antenna alignment is an important element of landing on the moon, Josh. We're expecting the high-gain antennas to be pointed towards Earth to confirm, but there may be a delay.
We are expecting some sort of delay. I had talking to the mission directors about how quickly we could receive a positive confirmation after this landing process is through, and there was some dispute over how long. The earliest was just about 15 seconds after we see timing of when the event is supposed to happen. So right now we're tracking about 5:24 p.m. Central Standard Time. So maybe anywhere from 15 seconds after that, maybe a few minutes, 2 to 3 minutes while we work to acquire that signal, because as you mentioned, the lander is going to a general area.
9 kilometers altitude.
9 kilometers altitude call from Tim Crane.
So they started at 10 and now they've gotten down to 9, and that just shows you that they're really just scrubbing off that horizontal velocity right now.
Navigation to make better decisions about this is an area with the least amount of slope. This is an area that's free of boulders and other obstacles. So it's making autonomous decisions about where to go.
3 minutes to go. Breaking one.
3 minutes call.
Everything's still looking positive.
Just to wrap that up, when the lander is making those decisions, Gary, it's also very difficult to track. We've been very fortunate thus far tracking communications to this point.
To wrap that up, Josh, 3 minutes, that brings us to just shy of 5:22 p.m. Central Time. We should hear that the Powered descent and initiation burn is complete. Then we'll begin the next series of maneuvers to get us towards vertical and terminal descent. It starts with pitch over.
And just looking at our notes here, we did go into this burn expecting pitch over at 5:21 and 57 seconds. So good call out on the timing of that maneuver. It's important to remember PDI starts an engine burn that does not stop until landing. So this is a throttleable liquid methane, liquid oxygen engine. We lit the engine at PDI, and while we are changing into a pitch over, vertical descent, and terminal descent and then landing, that is a throttle down to the lunar surface. And when we do get out of PDI, if we hear that call of PDI complete, good burn, everything after that is going to happen in very quick succession, Gary. The time it takes to go from pitch over to landing, or what we estimate landing to be, just looking at maybe 90 seconds is what we expect nominally.
3 minutes to touchdown.
There is some wiggle room. 3 minutes to touchdown call from the mission director.
Everything seems to be on track. We're getting close here.
For an on-time landing, that sets us a little after 5:23 p.m. Central Time.
Right, our notes going into this
We're
burn,
actually
5:23
15
and
seconds
25
ahead of
seconds.
schedule right now.
The autonomous operations, Josh, sets this to a clock. This is exactly what
So usually we try to cover interesting launches of new vehicles and also significant events. So this one qualifies.
Controllers were working so hard on to make sure HRN was working, pulling on extra resources that weren't originally planned for from those 2 laser beams from NDL. It appears and sounds like that solution is working, and the people working to patch that software were certainly under pressure.
Be near the pitch
clock
over
was
soon,
ticking
though.
as we went into that extra lunar orbit. It wasn't a situation where we could just sit in lunar orbit and try to solve our problems indefinitely, and it's sounding good so far on the call
2 minutes remaining till touchdown.
2 minutes to touchdown. That required a patch to be designed on the ground and uplinked to Nova-C to confirm that those laser sensors on NASA's navigation Doppler lidar could be routed to the terrain relative navigation and hazard relative navigation. That call out is fantastic.
Fighter, do you have an altitude reading?
We're waiting for the altitude call out from Flight Dynamics.
Standing by to see if we can get an altitude reading from Fido here. That's Flight Dynamics Officer Sean Stewart on Blue Team.
The pitch over should be happening right now. Should be getting a call out.
Confirm that looked like a pitch over gimbal.
Let's do it.
Sounds like we have some data that confirms pitch over. This starts the HDA process. That's hazard detection avoidance throughout
Man,
the
I'm
show.
getting
You've
nervous.
heard Gary and I talking about the problem that was
Yeah, we're
attempted
1
to
minute
be
to touchdown,
solved in
guys. 1
lunar
minute to
orbit,
touchdown.
making
It
the
should be
decision
coming vertical
to
right now.
not only postpone this show.
NDL indicates altitude of 1,000 meters.
Or 1 kilometer above the surface.
1,000 meters call out from NDL. That is coming from flight management. This is a system right now. NDL was not intended to be the primary landing system on this. Instead, we're using 2 laser beams from NDL and feeding that into that hazard detection and avoidance system that you see on your screen right now, with the lander making autonomous decisions about where it wants to land. That is generally
just seconds away now.
Remaining to touchdown.
Less than 1 minute remaining for touchdown.
So it's just coming down vertically now.
And again, that's the time of touchdown. It may take some time to actually confirm the status of the lander.
And in this process, we do have a deployment of Eagle Cam attempting to take the third-person images of Nova-C going down to the lunar surface. We are inside of 1 minute, Gary.
So listening for the call outs here.
Yes, we're well into blowdown.
And we're tracking here in the broadcast booth. The clock has reached the expected.
May take a minute for comms to reestablish. Standby.
Looks like
There it is, mission director beating us to it. We've reached the expected time of landing, but now is the process of waiting for comms, and we are in standby mode, as you
See
heard
if
it
we
from the
have
mission director,
confirmation.
Dr. Tim Crane.
They need to establish communication with the lander to make sure that it landed successfully. This can take a little while, so don't lose your shirts yet.
And 1 minute has elapsed from the notes that we have, Gary, of that original burn starting at PDI.
And you have carrier lock.
That's MD asking if we are getting the ground stations locked on to Nova C.
It's on the surface whether we like it or not right now. The question is, what is its state? Hopefully feet first.
That carrier lock call, Gary, we expect that to come from GroundNet or COM, that conversation possibly not happening on our public channel that we have access to. We're just standing by to hear that come through the channels as we approach almost 2 minutes since we estimated the landing time. We did get a few call outs on the side, folks coming into the room saying there was about a 2-minute forgiveness in our timetables.
We are checking our antenna reception.
They should be using
Checking
the
antenna
DSpace
reception
network right now, so not AT&T. But yeah, the delays of AT&T though. Sometimes this can take a while because the spacecraft does need to do some self-checking activities when it lands on the surface.
And we're standing by, Gary. We're standing by just as we approach 5:26 p.m. Central Standard Time. Given those mission directors' notes of the flexibility between what we were tracking, what we were given was just about 5:24.
All stations, this is MD. Please look back through your logs and confirm the last information you had, and we'll determine this is a comm outage.
And that's the mission director, Gary. These are our notes here of what we believed. We talked about the comm outages with the lander making autonomous decisions. This is the process of going through the last bit of data that came into Nova Control and working to verify, okay, this is the last bit of data. Where was the lander possibly going? How do we look for it and establish those communications? Nova C uses 4 antennas placed at the top of the lander that are designed to capture these communications. But we did expect this. We talked about it, that this is a communications challenge in it of itself, and right now we're standing by to hear that communications call out.
I hope it's some dust in front of the
Just a little more than 3 minutes
in front of the
from
dish.
the time of
and that's it.
when the clock reached 0 for Nova C landing on the moon.
But yeah, it's looking a little bit worrisome now. I'm getting a bit nervous. I really want to see that descent cam with a third person view. Like, man, if it didn't get down, that's really gonna suck. But they managed to scrub off all the velocity.
And we just checked with our team here in the broadcast booth, decided to let's stay on this. All the chatter we are not hearing on this public channel, Gary, all things indicate that we are working to solve a possible communications challenge in this moment. So we're going to continue to stand by.
But it could be as simple as just the lander landed safely, everything's all good.
Following along.
MD prime on IM-1.
Go for prime.
Yeah, I guess you polled the room looking for states, and we're going to go ahead and cycle the ground transmitter on Goonhilly and do some RF sweeps. Is that your plan?
That's correct.
Roger, copy.
This is the equivalent of turning
And
it off.
that's just
and on
what we
again.
had in mind in our notes, Gary, is that if we encounter a communications challenge, we mentioned how difficult it is to land on the moon and continually have those communications. What you just heard there is folks talking about using the Goonhilly Earth Station Limited dish in the UK to do a sweep looking for that signal. We mentioned that autonomous process of the lander reassigning itself somewhere that it believes is safe. Going into it, we heard that the HRN camera was
They're switching the comms dish they're trying to use to communicate with it. So a different part of the a different communication array.
With Intuitive Machines' TRN and HRN cameras, the laser rangefinders assigned to those are the ones that Intuitive Machines installed inside the navigation pods. the laser rangefinders were not activated. We went to NASA and asked to use 2 of the laser beams on the navigation Doppler LiDAR.
That's right.
And spent 2 hours in orbit.
Team, we're going to confirm our pointing vector with our antenna for post-landing.
Yep. We spent about 2 hours in orbit to solve that problem. We got good readings on the way down. And right now, we are working to confirm communications on the surface of the moon, roughly around the Malapert A region. That is the South Pole region of the moon.
That's right. What we do know is the powered descent initiation. We were following along on the status calls. We executed a pitch-over maneuver, and we're counting down the clock to a landing time of 5:23 p.m. Central Time. Well, Josh described those processes of working on the communications component to confirm data from the lander, pulsing the teams surrounding him to check
just based
the
on
status
the data that we
Nova
know,
C and the data that they were
it's definitely on the
receiving here,
surface.
Nova Control, to confirm
But we
landing.
don't know if
Part
it's
of that, Josh,
healthy
as you
on the
described,
surface,
is communications
or
were
if
standing by.
maybe there's just a communications problem.
Fido MD on IM-1.
QMD.
Yeah, I'm looking at our phase plane there for the last part of the flight. Looks like we had excellent pitch and yaw control throughout, but I did see a little bit of a roll excursion. Could it be that we landed off angle and roll in the final phase?
So I do see we had up to an 8-degree excursion.
So it looks like the vehicle
about to begin the
rolled
roll
a bit
maneuver,
more than
which is
expected.
about
Terminal phase.
the terminal phase, which is a large roll maneuver to get to landing attitude. That's the last data point I have. But up until that point, we were really solid.
Right. So terminal phase begins at 30 meters. Or post HDA.
Post HDA.
Post HDA.
400 meters.
Very good.
And that's a great conversation confirming.
That's good ground network. Good for box scan. Make that go.
Yeah, that was good confirmation of the process that we were very familiar with, talking about the attitude of the lander, making sure that those antennas are within direct line of sight with Earth stations, ground stations on Earth, excuse me.
So it looks like if they did have
Mission
a
director,
roll,
all stations are also updating our pointing vector with our dishes to make sure that they're tuned in on our final landing site.
if they did have a roll
There's
of the
a caller
vehicle,
searching for that communications back to the ground station.
they might actually have the antenna pointed in the wrong way right now. I think that's what they're concerned about right now.
An entire network dedicated to working these communications problems. It's been active this entire mission, and the largest, most powerful dish out of all of them is about a 64-meter dish in Australia. That time to search with that opportunity with the largest, most powerful dish, we're looking at about 12 to 13 hours after our estimated touchdown. So this is a process that we could be
Australia's
looking and
facing the wrong
searching
way
for
right
the
now.
lander's signal for confirmation for quite some time, but we're going to continue to listen in and stand by as our flight controllers are working with the ground station in the United Kingdom to work this issue, work this problem. It's another challenge, very similarly to the challenge solved just to make it this far.
Science of life, we have a return signal we're tracking.
Oh, this is good. Return signal is positive. Maybe Nova C figured it out. So yeah, basically they're searching for some sort of signal from the moon, and they're trying out the biggest dishes they have available to them. The biggest one is actually not available right now because it's in Australia and on the wrong side of the Earth right now. But I assume that, yeah.
We have an onboard fault detection system for our communications that after 15 minutes with lack of communication will power cycle the radios, and then after that for another 15 minutes it will then switch antenna pairs. So we have some time here to evaluate. We do have signal that we're tracking, so we'll see what happens.
So basically,
There's a great call out about the autonomous system.
basically they do have systems on board which will fault control. So it will do various things to try to get the
we were
radio
preparing ourselves for at AOS, to where the lander has systems in place to recycle its antennas, to switch antenna pairs, and that was very similar to what we thought we were going to need to do after acquisition of signal. When we separated from the second stage of the launch vehicle, if we made it to a certain point, the lander was autonomously programmed to start taking matters into its own hands, and that was the information that our mission director, Dr.
We're not dead yet.
We're also not dead yet.
I think it's going to be fine. Yeah, this is the beauty of intelligent robots. They can figure out when they can't be heard.
And the key here, Josh, is patience. It's 5:34 p.m. Mission Director Tim Crane confirming that it could take 2 phases of 15-minute increments to confirm the status of the landing. So we could be here, and we'll stand by and monitor as Nova Controls continues to work this issue.
Yeah, tense moments inside of Mission Control with the most qualified folks.
We're picking up a signal from our high-gain antenna and transmitter. It's faint, but it's there. So stand by, folks. We'll see what's happening here.
So I think that basically the evidence is pointing towards the fact that they may have rolled a little bit during the landing, so the antenna is not actually facing the right direction, and the antenna strength goes. So the antenna strength goes down quite a lot, depending on which way you're pointed. So now they have the onboard systems have fault detection systems that can tell that they're not being heard, and can actually switch between which antennas they use on board, and I don't know if they can actually change the angle of the antenna to the earth, so they can try to get that.
We're still standing by.
Stronger.
The last call from Mission Director Dr. Tim Crane was that we were getting a faint signal from Odysseus's high-gain antenna.
See, that seems to indicate to me that that they're just at slightly the wrong angle, because that high-gain antenna should be giving us a very strong signal. But if it's just off by a little bit, then obviously that signal's going to be cut off a little bit. So that seems to be a simple problem. And that probably wouldn't be working right now if they crash landed. So it seems to me like they probably stuck the landing, just maybe in a slightly different orientation than they were expecting. Another struggle of landing on the moon. It's always the communication.
All stations, this is Mission Director on IM-1. We're evaluating how we can refine that signal and dial in the pointing for our dishes. What we can confirm, without a doubt, is our equipment is on the surface of the moon, and we are transmitting. So, congratulations, IM team. We'll see how much more we can get from that.
So that's definitely a win.
An excellent call from our Mission Director, Dr. Tim Crane.
IM-1.
And over
Go
to our
Prime.
CEO, Steve Altimus.
Yeah, if I could just pass on a few words to the entire team in Intuitive Machines at Superbab and here in the Mission Control. What an outstanding effort. I know this was a nail biter, but we are on the surface and we are transmitting. And welcome to the moon.
Houston, Odysseus has found his new home.
An excellent call, and this is our team of Intuitive Machines mechanics and their families, their friends, everyone who has sacrificed so much to make it this far.
So we might get an update with a stronger signal here in the next couple of minutes, because the lander does have software on board which allows it to respond to faults and issues like this.
How about that call, Gary? That was something else, a faint signal. Now it's time to work on refining that signal. But Dr. Tim Crane, our mission director today, making the call. Odysseus has a new home.
It shows the disciplines of the flight controllers in Nova Control. They waited until there was absolute confirmation that there was a signal, and then that was when they took the moment to celebrate. We saw that it wasn't just the individuals in Nova Control that contributed to the mission. The contributions to enable the success of Nova-C's landing on the moon stretches far and wide. We showed, of course, some of the folks watching there, but really it extends even farther than this. A wonderful and truly amazing moment to celebrate. The U.S. has landed on the moon once again.
And to everyone, you mentioned it goes beyond just the folks.
So unfortunately, we're not going to probably get to see the surface in this stream, because of course what went wrong with this is the communications, which is of course the way they would transmit that photo. Yeah, right now they're just getting a faint signal, so they don't have a strong signal that they would need to actually send like big data. But the lander will be able to hopefully fix this problem just by changing the pointing of its antenna, which it will know after a couple of minutes more of not being able to communicate much with the ground control. So hopefully this gets solved relatively soon.
Of a strong lunar
but it's definitely landed on the moon. It's just unclear in which position it's landed in.
On the 8th day of a 250,000-mile voyage, a voyage along the Great Cosmic Bridge from the launch pad at the Kennedy.
This is how you know it's real too, by the way, because it's like happening in real time with the little problems that come along with the mission. And you never know what's going to get you. Like at this time, it looks like it could be as simple as just the lander just might have turned around a little bit as it was landing, and pointed the antenna the wrong way. And because of how far it is away, the direction the antenna points is actually really important, because you get way more signal when the antenna is in line, like directly in line of sight with the ground station. But if you're just 10 degrees off or something like that, the attenuation of the signal is a lot worse. So the gain that you get from having an antenna in the first place is you kind of lose a lot of the benefit. So yeah. In general, it was clearly a very successful landing sequence, and I honestly suspect that it is probably safely landed on the moon. And I'm looking forward to seeing what the photographic evidence of that will be soon, which I'm sure they will release if it's positive. Yeah, it'll definitely give a new perspective on what landing on the moon can look like. So I'm curious about what that's going to be.
Giant leap forward for all of humanity. Stay tuned.
All right, thank you, Administrator Nelson. Again, Nova-C in the United States has landed on the moon at 5:23 p.m. Central Time today, February 22nd, 2024. Congratulations to Intuitive Machines on the successful landing. Science and data gathering is already underway and will continue for roughly 7 days on the lunar surface, activating payloads and gathering important scientific data to help ensure future successes in Artemis missions. For more about NASA's CLIPS initiative, visit nasa.gov/CLIPS.
Gary, it's been quite a journey for all of us at Intuitive Machines. Thanks to NASA for the continued support to enable today's successful landing, and of course, everyone at Intuitive Machines, their friends and family who made all of this possible. That will wrap up our coverage of Intuitive Machines' IM-1 mission. Thanks for joining us.
So it looks like that's the end of the mission. Well, not the end, the start, in fact, because they are most likely successfully landed on the surface. We just have a little bit of a communications issue, most likely because the pointing of the antenna is just a little bit off. As I talked about before, it's probably just that the vehicle, based on the data that they were talking about in the situation room, it's clear that the vehicle rotated a little bit. So if this is it coming down, it just rolled a little bit, and that changes the way that their antenna was facing towards the Earth. So now, instead of getting a nice strong signal that confirms everything's good and we're getting data and everything's nice, they're just getting a really faint, weak signal. So they probably aren't really getting data out of that, but they just see that it's there. So now it's up to Intuitive Machines, it's up to the lander itself, Nova-C, to go through its error processing software and figure out to repoint that antenna such that it can receive a good signal. And it has time windows for doing that every 15 minutes while it's on the surface. So I'm sure that if you check social media over the next couple hours, it'll probably start sending some good data, and they'll probably announce something about it. But yeah, if you're looking for the beautiful footage of it landing on the surface, I think you might need to wait a couple of days, because I'm sure that's how long it's going to take for them to actually get that data back. Considering that the problem right now is with the communication array, I wouldn't expect that to be coming out, in the next couple hours or something. First, they have to figure out and solve that problem. But at least they have demonstrated that the vehicle works, and the system for getting to the moon works. And it's probably something that they could probably just repeat. And they have 2 more landings, which are scheduled for this year, which they will probably undertake, considering the success that they had so far. So I'll be looking forward to seeing how this goes in the future. And maybe they'll be a little more confident in live streaming the landing, maybe, on their future missions. I don't know. We'll see. Yeah, how do they deal with fuel sloshing during the landing? Well, yeah, actually a combination of things. So first of all, they actually don't really have to deal with sloshing, because what they do, and if you were listening to what was happening in the operations room, they actually first settle the tanks. So they basically just fire these little tiny helium thrusters. They have like an extra tank of helium on board for pressurization, but they also use it for attitude control. So what they do is they use that helium to just give a little bit of push, which causes all the propellant to kind of settle into the back of the tank before they start the engine. Because of course they need the fluid back there near the inlets, otherwise they could really mess up the rocket and be sucking in gas and stuff, and that's not good. So that's how they get around that problem. Yeah, usually spacecraft always do little things like this to try to solve things like sloshing. But they also had those special fancy sensors inside of their tanks, which were measuring the amount of fluid in the tank on top of that, in order to determine just how much propellant they have in order to execute the burn. And that's going to be something that's obviously important when we start doing more lunar activities, because obviously we're going to have lots of liquid propellants that are going to be in 0G, so we need to know how much is in the tanks in order to operate them properly. So all of those systems seem to be working properly, as they did achieve a descent to the surface. So hopefully they can figure out how they can get their communications working. So hopefully they can get some nice data coming out of it over the next couple of days. Anyways, guys, it's been great following along with you, and we hope that you're able to continue to be inspired by Intuitive Machines and the Nova C lander. And it's great to see that America has finally made it back to the moon after 52 years. And we hope they do many more lunar activities and don't randomly cancel the program just because, there's other people in the world aren't going there. But now there's lots of people in the world going, so hopefully they'll be incentivized. Yeah. Anyways, we've learned some stuff, and we're hoping to continue to develop our student group so that one day we can do something as inspirational. Anyways, in the meantime, remember to keep expanding your horizons.